Hello everyone. In this example, we will show how to do the network analysis in project management when the activity time is not determinate, where we call it probabilistic time, which means the finish time at each activity has some variations. Now, this is an example of how to do the calculation. Now in this diagram, we show the expected time and variance for the major activity of an R&D project. And we need to determine the probability that the project completion time will be 50 weeks or less, or more than 50 weeks. Now look at the diagram here. Now this is not an AON diagram. It is activity on error, where we use each error to demonstrate a major activity. Now, the first one, we use it as example. Each error we have two numbers. The first number is mean, and the second number is a variance. So the activity 1, 2 will take an average of 16. We just use weeks to finish it. And the variance for this activity is 0.69, which means it has some variations. When we talk about the time spent to finish this activity, we only know its average is 16 weeks, but it has some variations. And similarly, we have other mean and variance for other activities. And we have the relationship among the dependence relationship among different activities as well. Now, from this chart, we can see that there are three passes basically: 1, 2, 5, 8, 1, 3, 6, 8, and 1, 3, 4, 7, 8. These are the three possible passes to finish the project. Now, the next question is, how do we decide what will be the probability that we can finish the project within 50 weeks? Now, we basically need to first understand what will be the probability that we go through each path within 15 weeks, which means what is the probability for us to finish activity 1, 2, 5, 8, 1, 3, 6, 8, 1, 3, 4, 7, 8 within 50 weeks. Now we take a look at the calculation here. Now we have different paths, the three paths listed here. For each paths, we can calculate the mean time. It's straightforward, just the addition of all the given times. And with all these given times, we can calculate the mean. For example, path 1, 2, 5, 8 includes three activities: 1, 2, 2, 5, 5, 8. And the corresponding time on each activity are 16, 11, and 24. So the total time is 51 weeks, which is the mean time. It tells us it takes average 51 weeks to finish the three activities on path 1, 2, 5, 8. Similarly, we can calculate the mean time for the other two paths, which are 49 and 41 respectively. Second, we calculated the corresponding standard deviation. Now, remember, in previous chart, the given numbers are the variance. They are not standard deviations. So when we calculate it, we can add them up to get the corresponding variance for the path. So for path 1, 2, 5, 8, the variance of the path will be 0.69, 0.69, and 0.11 add up. However, when we describe a distribution, we usually need the standard deviation. So that is why after we add everything up to get the path variance, we need to take square root to calculate the standard deviation. So we can basically calculate the standard deviation for each of these three paths, which are 1.22, 0.6, and 0.85 respectively. Now, why do we need these numbers, and or how to use it? Remember, due to the sampling theorem, we can assume that the path time distribution is approximately normally distributed, which means if we take a look at the time we spend to finish pass 1258, we can assume that this pass time is a normally distribution with a mean of 51 weeks and a standard deviation of 1.22 weeks. So that is what we can use to describe this pass time distribution. With these two parameters and the normal distribution assumption, we can go ahead and calculate the probability that for this pass to be done within 50 weeks. Of course, we just look at the chart, the plot at the bottom, which shows the relationship between the z-value, the specified time, pass mean, pass standard deviation, and how it is mapped in the normal distribution. Now the shaded area is the probability of completing the pass by the specified time. Now, given this information, we can go ahead and do the calculation. First, calculate what's the probability to finish each pass within 50 weeks. Now, pass 1, it is normal distribution with mean of 51 and standard deviation of 1.22. We can calculate the corresponding z-value equals to negative 0.8197. This actually will give us a probability of 0.2061. Similarly, we can calculate the probability to finish pass 1368 within 50 weeks, which is 0.9525, and pass 13478 will roughly be 1. These probabilities are the corresponding probability that we finish each of these three passes within 50 weeks. However, it is not the probability that we finish the whole project within 50 weeks. How to calculate the probability that we finish the whole project within 50 weeks? Basically, we need to multiply these three probabilities together. Why? Because to finish the whole project within 50 weeks, it requires us that all three passes need to be finished within 50 weeks. And the probability that all three passes will be finished within 50 weeks will be the multiplication of the three individual probabilities, which will give us a final probability of 0.1963, which means the probability that we finish the whole project within 50 weeks will be 0.1963. So with this information, we can take one further step to calculate the probability that the project will be finished more than 50 weeks. It's just 1 minus the probability that the project will finish within 50 weeks, which is 0.8037.